9.3a, geometric sequences. All right. Before we did arithmetic sequences. And arithmetic sequences, what did you do from term to term? You added them. All right, so for a geometric sequence, we're going to multiply. And what we multiply from term to term is called the common ratio. What you multiply from term to term is called the common ratio. Now, sometimes, before in our common difference, we take our next term, subtract our previous term, and that would give us our common ratio, our common difference. This time, we can actually take our next term, divide it by our previous term, and that will give us our common ratio because it's being multiplied from term to term. So now, sometimes when we have students, what if I have 16 for 1? What would be my common ratio from term to term on this? It'd be 1/4. Okay? Don't say divide by 4. That's not really what's happening. It's being multiplied by 1/4 for our geometric. You following me? All right, so we needed to write our a sub n. You found out how important it was with arithmetic. It's still important for geometric. So our a sub n is equal to my first term, a sub 1, times whatever my common ratio, what's being multiplied from term to term, to the power of n minus 1. Now, it's to the power of n minus 1 because if I substitute in 1, most time in pre-calc we start with the first term instead of the 0 term. If you substitute in 1, you get r to the power of 0. And r to the power of 0, no matter what r is still what? 1. So you're left with a sub 1. All right, so that's why it's an n minus 1 instead of just an n. All right, pretty good? Do this. So I need a reader. Thanks, Kate. Go.
Write the first 5 terms of the geometric sequence whose first term is a sub 1 is equal to 3 and whose common ratio is r equal to. Then graph these terms.
No, we're not doing that. All right, so I'm going to build my a sub n. Even though you don't really need to on this one, we're still going to build it. So my a sub n would equal my first term of 3 and then times 2 to the power of n minus 1. All right. So my first term is said to be 3. And then what do we have to do from term to term? We need to multiply by 2. So if I multiply by 2, my next term is 6 and then 12 and then 48. Now, sometimes it's nice to have this a sub n to find a certain term. For instance, if I had to check my fifth term, if I substitute in 5 in for n, it'd be 5 minus 1, which is 4. 2 to the power of 4 is 16. 16 times 3 is 48. Hey, it worked. All right. All right, let's look at this next one. Jacob, go for it.
Find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05.
Good. All right, so we need to find a sub 15 eventually. All right, but before we find a sub 15, what should we probably build? I should build my a sub n. So my a sub n would equal 20 times 1.05 to the power of n minus 1. And so now that I have that a sub n, I just substitute in 15. Put it in your handy dandy calculator. Go. What do we get, Jomar?
39.5986.
Good. All right. Again, we round to the 4th decimal. All right. Whether it's geometric or not, we're going to find the common ratio, and then we're going to give the rule. So the first sequence we have is 2, 4, 8, 16.
I can always see it.
Is that geometric?
Yes.
Yes. All right. What would be the common ratio of this one? 2. Okay, so the common ratio is 2. And so we need to write our rule. So a sub n would equal 2 times 2 to the power of n minus 1. Now, most of the time on a free response type of question, that is good. It's good. You don't have to do anything to it. But I'm going to go back to Algebra 2 / the beginning of pre-calc. So we're going to talk about these exponential rules. So this 2 is really a 2 to the power of 1. Agreed? And then this is really 2 to the power of n, and then 2 to the power of negative 1. All right? If I would separate them like that, that's really what's happening. And if I have 2 to the power 1 and I have 2 to the power negative 1, what happens to those things? They cancel. So I'm left with 2 to the power of n. All right. So every now and then they might like convert the rule to just be a power of n.
Simplify 2 to the power of n.
All right.
It simplifies 2.
Good. All right. So let's work with this next one. I got 12, 36, 108, 324.
What's the here?
Is that geometric?
Yes.
Whee. And what's my ratio?
3.
My ratio is 3. And so my a sub n would equal 12 times 3 to the power of n minus 1. All right. All right. So most of the time I'm good with it like that. However, this is really 12 and then 3 times n, or 3 to the power n, and then 3 to the power of negative 1. Well, 3 to the power of negative 1 is really 1 over 3, remember? And so 1 over 3 messes with the 12 to then be what? 4. And so this is actually the same thing as 4 times 3 to the power of n. All right? Negative 1/3, 1/9, negative 1/27, 1/81st.
Can always see it.
So, is it geometric? Yes.
Yes.
All right.
I already know what the ratio is.
What's my ratio?
Negative 1/3.
Fantastic. All right. And so,
Oh, it's in different language. I love how you put yes in different languages.
thanks. All right. So, what's my a sub n? Negative 1/3 times negative 1/3 to the power of n minus 1. So, if I were to rewrite that one, I'd have negative 1/3 to the power of 1, then negative 1/3 to the power of n, and then negative 1/3 to the power of negative 1. And so this would actually simplify to?
Negative 1/3 to the power of n.
All right. All right. Try these. Evan, help me out.
For the top one, the common ratio is 5. So the rule would be a sub n is equal to 2 times 5 to the power of n minus 1.
Good. All right. If you actually converted it, it would be 2/5 times 5 to the power of n. All right. All right. This next one, pick somebody.
John.
Jomar.
I got the common ratio as negative 1/2. So it would be a sub n equals 1 times negative 1/2 to the power of n minus 1.
All right. And if you actually converted it, it would be negative 2 times negative 1/2 to the power of n minus 1. All right. All right. Pick somebody.
The ratio is negative square root 7, and then the formula is a sub n equals 1, negative square root 7, n minus 1.
Good. All right. And if you would actually convert that, it would end up with negative square root 7 over 7, and then negative square root 7 to the power of n. All right. All right, let's keep going. So now we're going to find the 12th term of this said geometric sequence. And this geometric sequence starts out with 5, 15, 45. Well, we eventually need to get to 12. So a sub 12 is what we're looking for. But what should I probably build like we did in the other sections? We should probably build a sub n. So a sub n would equal 5 times, what's my ratio here? 3 to the power of n minus 1. So now all we're going to do is substitute in 12. We're going to substitute in 12. Jillian, what do we get? I think it's a big number. 885,735. Good. All right. All right, let's look at this next one. So now I'm given 1/8, or 1/2, I'm sorry, negative 1/8, 1/32, negative 1 over 128. And I'm trying to find the 8th term. All right, I'm trying to find eventually a sub 8. But before I find a sub 8, I should build a sub n. And so what is my a sub n? 1/2, and then times negative 1/4 to the power of n minus 1. And now I'm going to substitute in what? 8. And so when I substitute in 8, I'd have 1/2, and then I'd have -1/4 to the power of 7, basically. All right? Now, this is what I would highly suggest because your calculators can't handle it. Work with the numerator and denominator separately. Okay? And what I mean by that is work with like 1 times -7 to the or -1 to the power of 7. And so what do you have up top going on? You got -1. All right, so we have -1 up top, and then work with the denominator separately. So then you type in 2, and then times 4 to the power of 7. Are you following me? Your calculators are going to give you like a scientific notation if you just try to put it in all the way together. All right, it's not going to work for you. All right, so work with the numerator and denominator separately. And so what did we get for our denominator? 32768. All right. Okay.
The fourth term of a geometric sequence is 125, and the 10th term is 125/64. Find the 14th term.
All right, fantastic. So I'm given the a sub 4 is 125, and I'm given a sub 10 is equal to 125/64. Now, this is a geometric sequence. Okay, I eventually need to find a sub 14. Okay, for when we had common difference with arithmetic, remember I kind of went off to the side and I said, hey, 6 terms, so forth. All right, I'm still going to do that a little bit, but it works differently. It's not just kind of like a slope before. Now it's kind of exponential. Okay, so it's being multiplied each time. So how many times did I use my ratio? I used it 6 times. Does everybody see how we did that? All right, I used it 6 times. So my a sub 10 was 125/64, and my a sub 4 was 125, and I'm using my common ratio 6 times. Because it's exponential, because I'm being multiplied each time. Okay, that's what's happening. All right, so I need to solve for r. So what's my first step to solve for r? I kind of need to isolate it. I need to divide by 125. So when I divide by 125, I'm left with 1/64. It's equal to r to the power of 6. Well, how do I get to r? Not a square root, but a 6th root. Okay, so I need the 6th root. Now, on your calculators, you don't have a 6th root. Okay, you actually need to raise it to a power of 1/6. All right. So you raise 1/64 to a power of 1/6. That's probably what you're going to input. And so what do we get for our common ratio? 1/2. All right. So now that I have this common ratio, now I can start solving it a little bit. Now, I don't actually have to get back to a sub n. I don't need to know what my first term is. You can, but I wouldn't go that way to Tampa. I would kind of look at which one's closest. All right, I can use both if I really wanted to, though. All right, so I'm just going to use a sub 10. Okay, that's what I'm going to use. All right, so a sub 14 would be a sub 10. So I'm going to say 125/64. But how many times am I going to use this ratio? I'm going to use it 4 times. Okay, because going from 10 to 14, I'd be using it 4 times. Are you following me? So then I'd have 125/64, and then I'd have 1/2 to the power of 4. And that would give me my a sub 14. And again, work with your numerator and denominator separately. All right? So we have 125 times 1 to the power of 4, which is still what? 125. And then I have 64 times 2 to the power of 4. Well, 2 to the power of 4 is 16. 16 times 64. This is where we're going to need to calculate it. And what do we get? 1024. All right, so there's how my a sub 14 is. Okay? Now, I want to kind of show you this a sub 4 if I wanted to find a sub 14, I could also use my a sub 4 of 125. And then how many times would I actually use my ratio? I'd use it 10 times. Guess what? This would still get you to that. All right. So does it really matter which one you use? Not really. All right. Just pick one and figure out how many ratios you're going to have. And I'm giving you a sub 4 is equal to negative 18. And a sub 7 is equal to 2/3. All right, to go from a sub 4 to a sub 7, how many times am I using my ratio? I'm using it 3 times. So to get there, I'd have 2/3 is equal to negative 18, and then my ratio 3 times. All right. So then our first step is divide by negative 18, and I end up with negative 2 over 54 is equal to r cubed. Now, I would highly recommend you simplify this first. So this actually simplifies to negative 1 over 27, and that's going to make your life a little easier. And so then after we cube root it, when we cube root each side, which is really raising the power to 1/3, I end up with r is equal to negative 1/3. All right. Now, how many of you guys actually used a sub 4 to get to a sub 6? How many used a sub 7? All right, I'm going to show you both ways. All right, it doesn't really matter which way you go. So I'm going to say a sub 6 is equal to my a sub 4 of negative 18. And then I'm using my ratio of negative 1/3. How many times? Twice. I'm using it twice. All right. And so when I do that, I put that in my handy dandy calculator. And what do I get? I get negative 2. All right. And then the other way to Tampa is you find a sub 6 equals, I'm going to use a sub 7 this time. And then I'm going to use my ratio. How many times this time? Negative 1 time, because I'm going backwards. All right. So if I raise it to the power of negative 1, guess what? I still get negative 2. All right. Because I went backwards, that's why it's raised to the negative first power. All right. Pretty good. Worksheet 9.3a. Worksheet 9.3a.